All right, so here we are with Unit 1, Lesson 4, and we're going to look at just one topic in this lesson. We're going to look at something called scientific notation. They're not big on it on the Regents exam, so we're not going to spend a lot of time on it, but you should have a general kind of knowledge of um, how to write numbers in scientific notation and how to convert numbers in notation back to normal notation or standard notation. So let's take a quick look at it. And scientific notation really is a way of writing extremely large or extremely small numbers. For example, one of the numbers that we're going to be working with later in this year is Avogadro's number, and this is Avogadro's number right here. It's 6.02 times 10 to the 23rd atoms is something that we call a mole. We don't need to worry about that. But this is, as you see, an example of a number in scientific notation. And we're going to take a look at how to change that to standard notation and in the opposite direction. So if we look at it, for example, the number 1 million, that's called standard format. And that's how you normally see numbers. If we were to write that in scientific notation, it would be 1.0 times 10 to the 6th. So let's take a look at that quickly. Let's see if we can figure out where the 6 comes from. Now notice there's no decimal point in this number, but we all know that the decimal point is here. And if you look at the decimal point, and let's move it over to the left, one place, two places, 3, 4, 5, 6. If we move the decimal point here, that's 6 places. And notice now that the front number, which is called, this is called the mantissa, it's not something you need to worry about, is 1.0. So if you see a number in scientific notation and the exponent is positive, that means you move the decimal that many places to the right. If this was a negative exponent, for example, if this was a negative 6, you'd move the decimal 6 places but to the left. So positive exponent, you move it to the right. Negative exponent, you move it to the left. That's something that you're going to have to memorize. So how do you get this first number, the 1.0? Notice that in this number, we left out almost all the zeros. There's a reason for that we'll talk about when we get to significant figures. So you're always going to move the decimal so that the beginning number, the mantissa, is between 1 and 9. So if you look at this, this is obviously between 1 and 9. And then you're going to raise the exponent, which is the number on the upper right-hand corner. And you're going to have to figure out, well, is it a positive exponent or is it a negative exponent? Well, if you look at, if it's a very large number, if it's a large number, basically if the number is more than 1, it's going to be a positive exponent. If the number is less than 1, meaning point something, it's going to be a negative exponent. And I think you'll see this in the examples that we have here at the bottom. So if you look at this number here, that's a very large number. That's normal notation. And here it is in scientific notation. Let's look at the 11. Well, obviously the decimal is here, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have to move the decimal between the 1 and the 2 because remember the number, the mantissa, has to be between 1 and 9. If we move the number here, that would be 12.3. That's not between 1 and 9. So I know I have to move the decimal to between the 1 and the 2. That's where you get this from. And I moved it 11 places. And obviously this number is much larger than 1, so it's going to be a positive exponent. And we'll talk about later on again why I left out all the zeros when I wrote it in scientific notation. Here's a smaller number. Now, obviously, this is less than 1. Any number that begins with 0 point is going to be less than 1. That means it's a negative exponent. So here is the decimal. I have to go 1, 2, 3. If I put the decimal here, that's going to make the number, the mantissa, 4.7, which is between 1 and 9. I don't want to move it here because that would be 0.47. That's less than 1. And I moved it 3 places, but because it's a very tiny number, it's going to be a negative exponent. Let's take a look at the examples at the bottom here. And hopefully I'll be able to figure out how to use the writing part of this. Okay, maybe not. Okay, let's get rid of that. Okay, so if we, apparently I can't. So let's see, what do we got here? Fool around with the thingy. Oh, look at that. Okay. All right, so it's not working out very well. So let's see what we got here. So you have if you take a look at this number, you can see that this is an extremely large number. So you know the exponent is going to be positive. This is a very small number, so you know the exponent is going to be negative. Again, a large number, positive. So let's take a look at this one. Notice that the decimal is not written, but it's right here. So let's see. 1, 2, 3, 4, 5, 6, 7. I have to move it between the 3 and the 4 so that it is between 1 and 9. So the first part of my answer is going to be 3.4. How many places did I move it? 1, 2, 3, 4, 5, 6, 7. So my answer would be 3.4 times 10 to the 7th. Number 2. Obviously the decimal is going to have to go between the 6 and the 7. And I'll move it 1, 2, 3, 4, 5, 6 places. And since it's a small number, I know it's going to be exponent is negative 6. So my answer would be 6.7 times 10 to the negative 6. Last one. The decimal's here. I'm going to move it 1, 2, 3, 4 places. And it's a large number, so it's going to be a positive 4 exponent. And I moved it 4 places. So my answer here would be 2.5864 times 10 to the 4th. Now, why did I include all the numbers? Well, notice that the ones I left out here were zeros. And that's what we're going to look at in scientific notation. Let's look at the next one. Now we're going to do it opposite. Now we're going to write them in normal notation. So remember we said if that's a positive exponent, that means you move the decimal to the right 8 places. That's a negative exponent, that means you have to move the decimal to the left 11 places. So if we move this, it's going to be 5, 7, and then 7 zeros after it. Let me attempt to figure out how to draw this. Oh, here we go. Okay. So it's going to be 5. What's going on? 5.8 times, I'm sorry, it's going to be 5, 7, and then 7 zeros. 3, 5, 6, 7. So there's a comma, comma. So the answer is 570,600,000. 570 million, that's the answer right there. That's a 0. So you have 1, 2, 3, 4, 5, 6, 7 zeros. Remember the decimal was originally here, but we had to move it 8 places. Now if we look at this one, we have to move it 11 places. So you're going to start out with 0. And we have to move it 11 places to the left because it's a negative exponent. So we're going to have 10 zeros, 2, oops. I don't know what happened. Did something? Hold on. Okay, so that's a 0. Don't know what happened. 4, 5, 6, 7, 8, 9, 10, and then 6, 3, oops, 4. So if you count them up, the decimal was originally here, right? And we had to move it 11 places. So that's our answer. Get rid of the writing. There we go. And this shows you if you're going to use a calculator. Obviously, most of you have a fairly decent calculator, and it will probably do the scientific notation for you. As long as it's not a graphing calculator, you're welcome to use it. And that's it.